Good morning. Now, good morning. We are going to discuss about that is a digital logic and microprocessor and digital fundamentals. In this topic, we are going to discuss about that is Karnaugh map, K map. So, what are different types of K maps in SOP and POS? So, we are going to discuss about the module 1 in digital fundamentals. So, K map is we are going to discussing. First one, that is what is meant by K map. So in many digital circuits and practical problems, we need to find expressions with minimum variables. So we are going to reduce the Boolean expressions. We are going to minimize the Boolean expressions of 3 to 4 variables very easily by using the K map without using any Boolean algebra theorems. So this is a simplified form of K map. So in order to avoiding the Boolean expressions and remembering the formulas, we are going to reducing the expressions by using the K map. So it is the tool which is used in digital logic to simplify Boolean expressions. It helps to simplify logic into simpler form by organizing grid from truth table values, and it also helps to create minimal Boolean expressions by identifying the patterns. So this is a general introduction about K map. So K map, next one, K map can be two forms. It can be obtained in the form of two forms. First one, that is SOP form. SOP means that is sum of product, and POS, second one, that is POS. POS means that is product of sum. So let we going to discuss about one by one. First one, that is solve what are steps involved to solve a Boolean expression using Karnaugh map, K map. So there are different steps and different rules and regulations is there for using to finding the K map Boolean expressions. First one, step 1, that is identify the number of variables. So the number of variables may be 2 variables, 3 variables, 4 variables, or 5 variables. Determining the how many variables are given, that is 2 variables and 3 variables, 4 variables or 5 variables are in the Boolean functions. Accordingly, based on after identifying the number of variables, accordingly draw the K map. So that is 2 cross 2, that is we are forming the table. That is 2 cross 2 means there is 2 column and 2 rows. So for 2 variables, and 2 cross 4 for 3 variables, and 4 cross 4 for 4 variables, and etc. So this is the first one, identifying the number of variables, and based on the number of variables we can draw the K map table. So based on the table, based on the variables, that is A, B, C, D, like that. And step 2, that is fill the K map. So fill the K map, that is express the function in canonical form. So sum of min terms or product of max terms. Next one, place ones in the K map cells corresponding to the min terms, or zeros in the max terms. So after plotting the K map table, we are going to assign the table, that is assigning the values, that is 0 0 0 1 1 1 1 0. So based on that we are going to assigning the values. After that, the number, what are the number given, so in that number we are going to place the values once, and what are the numbers not given, we are going to place the values as 0. By using 1, we are going to determining the min terms, and for SOP, that is sum of product, and for zeros we are going to determining the max terms. So that is a product of sum. So this is this arrangement follows gray code order. So why we are going to follow the gray code order means there is only one number change for each and every step binary digits. So we are going to follow the gray code order here. So gray code order means first one 0 0, next 0 1, next 1 1, next 1 0. So this is the gray code order. And next one, that is step 3. In step 3, there is a group adjacent ones. So we are going to grouping the ones based on the SOP and POS value. For zeros for POS, ones we are grouping ones for SOP, and we are grouping 0 for POS. form groups of 1, 2, 4, 8 and 2 power n cells that contain ones for SOP simplification. Each group must be a power of 2 in size, as large as possible. As large as possible means that is we are going to map 8 ones or 4 ones or 2 ones, so like that. So first one 8 ones, like that. So that is as large as possible, and adjacent either horizontally, vertically or circularly. So edge wrapping is allowed. So this is the method for mapping the ones. On step 4, write the simplified expression for each group, eliminate the variables that change within the group, and write the product term for SOP, sum term for POS. Next, step 5, combine all the terms. So add all the simplified product terms for SOP and multiply sum terms for POS. So this gives the minimized Boolean expressions. So after performing these steps, we are obtaining the minimized Boolean expressions, and we are going to see about that is SOP form, sum of product form. So in sum of product form, that is way to simplify and write Boolean expressions using AND to combine input and output to combine the results. Kmap for R for R to combine the results. Kmap for two variables. So this is the Kmap for two variables table. In the two variables Kmap for squares or 4 squares are constructed. Each square contains one term of expression within two variables. So that is two variable Kmap. That is where the variable means that is AB. That 4 terms that is 0 for A bar and A for 1. A bar for 0, A for 1. So by plotting the terms, B bar for 0, B for 1. So by plotting, that is what is the values we are obtaining is A bar, B bar and A bar B, A B bar, A B. So this is the two variable Kmap in SOP format. And the next one, that is 3 variables. In 3 variables, that is what are the 3 variables? X, Y, Z. So here X, Y, Z, there is 8 combinations of results can be obtained. That is first one X bar, Y bar, Z bar, and X bar, Y bar, Z, X bar, Y, Z, X bar, Y, Z bar. Like that, we are obtaining up to 8 results we are obtaining for the 3 variable Kmaps. And next one, that is 4 variable Kmaps. In 4 variable Kmaps, we are applying the input as A, B, C, D or some other form, W, X, Y, Z form. So any form we can applying the 4 variables and obtaining the results based on the values 0, 0, 0, 0 and 0, 0, 0, 1. For the values of 0, we are mentioning the bar value, W bar, and for values of the 1, we are mentioning Y, Z, like that. So 0 is complementary term and 1 is the non-complementary term for plotting the Kmap variables for the 4 variables. And next one, POS form, that is product of the sum form. So POS form is where to simplify and write the Boolean expression using OR gate to combine the terms inside parentheses and then AND to combine those groups. Kmap of 2, this is the Kmap of 2 variables. Here we are going to mapping the zeros only. So in SOP form, mapping of 1 can be done. In POS form, that is mapping of 0 can be done. That is for the value of 0 we are mentioning the value of A, and for value of 1 we are mentioning A, which is opposite to the SOP format. And here we are going to write in the OR gate operations. So OR gate operations means that is A plus B and A plus B bar, A bar plus B, A bar plus B bar. So OR gate operations can be performed here. After performing the OR gate operations, finally we are going to combine write the equations in the AND format. Then this is the Kmap of 3 variables. Here also the similar, that is A, B, C, 3 variables can be applied, and here that is 8 boxes is there. So there is 8 boxes, 0 to 1 values up to 0 to 1 binary, 0 to 7 binary values can be plotted in the Kmap of 3 variables. Next one, that is Kmap for 4 variables. Here the 4 variables, that is A, B, C, D can be applied here. Based on the values, the operations can be performed. And next one, the advantages of K-map. So what is the advantages means makes logic simpler. It makes the complicated Boolean expressions simpler, minimizes logic gates, simplifying the logic gates, and reduces the errors and time saving, no need for Boolean loss. Next, what are the disadvantages in K-map means there is limited to fewer variables only. So it is suited for 2 to 4 variables, and above it the process may be hard and complicated to manage, not suitable for all the functions. In some cases, the hard to group terms correctly, leading to errors and making simplifications difficult, and space limitations. As the number of variables increases, the K-map grid becomes too large to handle easily and requires careful grouping. Sometimes incorrect grouping of terms can be cause mistakes in logic simplifications. So these are all the disadvantages of K-map and some questions for practice. So hope that is define a Karnaugh map, and how many cells are required for 4 variable K-maps, and why is gray code used in the K-map cell arrangement, differentiate between min terms max terms in context of K-map, what is meant by grouping of K-map, state the rule for size of grouping formed in K-map, what is the advantages of K-map over Boolean algebra simplifications, how many groups of non-adjacent ones can be combined in a 3 variable K-map, state the difference between SOP and POS simplification using K-map, what is a minimized expression for pair of 2 adjacent ones in K-map. Hope you are all understanding. Practice these questions. Thank you.